Welcome, welcome, welcome. Thanks everyone for joining my talk about building a robust data pipeline with dbt, Airflow, and great expectations. I have a lot of content material to go through, so this is going to be a little bit of a whirlwind tour of different things. The presentation kind of has two parts. Part one, I will convince you that you should test your data. Part two, I will show you how to do that in a data pipeline that consists of dbt, Airflow, and great expectations. So let's get started. This is I consider myself a modern day data Martin Luther. These are my not quite 99 thesis or 90 theses, but my 3 theses. And thesis number 1 is you should test your data. No, really, if you are not doing that already, I don't know how you sleep at night. If you don't believe me, then strap in. I'm going to give you a couple of examples and hopefully a couple of good reasons as to why you should really be testing your data. First of all, we have a few quotes from some of our users. This one's saying, our stakeholders would notice data issues before we did, which really eroded trust in the data and our team. So eroding trust is really an issue that is caused by data, any kind of data quality problems. I also hope that anyone here in your audience who works with data on a daily basis recognizes themselves and recognizes some of the issues they have encountered. If you've never encountered any issues, if none of this sounds familiar, please do talk to me. I'm very curious to hear how you work with data and never have any data quality problems. Secondly, bad data quality also incurs costs. So we've heard from our users that they actually had to rerun data pipelines after finding data quality problems very late in the game. And that would incur actual costs for the compute environment. So you have actual dollar values attached to that. And finally, bad data quality, and I think this is one that us data professionals, data practitioners probably notice the most. It can grind you down, like just fixing data pipeline bugs all the time, trying to root cause problems and just noticing stuff very late in the game is really soul crushing. I still remember the great Thanksgiving data break incident of 2018 when my entire team was working a whole weekend around Thanksgiving to fix our monthly data delivery. So this is a true, we call it our data horror stories. So hopefully that has given you some idea as to why you should be testing your data. However, here's my second thesis. Data testing is kind of hard. I can show you how to get started, but oops, sorry. Oh, there you go. I skipped a slide. The problem is, like, where do we start, right? We all know we should be testing our data, but there's so many questions like, which tool should we use? How do we know we're testing the right thing? What do we do when the test fails? Who owns this whole thing? How do we keep them up to date? How do our stakeholders actually find out about the state of the data? So there's a lot of stuff going on when you embark on a project, on a data quality project, in order to actually figure out like what to do and where to get started. So again, thesis number 2, data testing is kind of hard. And now I'm actually going to show you how to get there. So like I said, for the second part of this presentation, I am going to talk about data testing in what we call the DAX stack, which is dbt, Airflow, great expectations. If you follow me on Twitter, you know I've been going on about this for a while. Please forgive me. The one thing I would like to call out here is that while this talk is specifically about Airflow, it doesn't actually matter what kind of workflow orchestration tool you use. In fact, basically all of them do work with dbt, do work with great expectations. So a big hello to our friends at Daxter, Prefect, Cadro. Nick from Daxter is actually giving a talk right after this about dbt and Daxter. So the concept itself is pretty platform agnostic. I just happen to be using Airflow quite a bunch and have some experience with that in practice. So I'm using Airflow as an example, and the whole DAX stack obviously is also just a very nice acronym. So let's get started with that. First of all, I'm going to give you a very brief overview of all the individual technologies. dbt, as you know, stands for the T in ELT. You know this already. You're all familiar with Jaffle Shop. You probably all learned what Jaffles are from dbt, as I did. I will not explain dbt to you. You know this already, and there's a lot of people here who can explain that significantly better than I can. So dbt is our first component in our stack. Secondly, we have Apache Airflow, which I also assume a lot of you are already familiar with. Airflow is a workflow orchestration tool. It's all open source. I kind of call it cron on steroids. It does, so if you've ever written cron jobs in order to do some scheduling, Airflow kind of does that plus more. So you can do the scheduling, you can do conditionals, you can do a lot of branching, you can do alerting. So it basically just gives you a really nice way to orchestrate your workflows. And like I said, a lot of other workflow orchestration tools work in a similar way. And just a quick plug, a lot of the reason why there are other workflow orchestration tools exist is because Apache Airflow does have some shortcomings that other tools are trying to address. So basically, as you can see here, in Airflow, you can also build a DAG, yet another DAG, where you can do branching, you can do joins and everything. And the way this relates to DBT on the DBT DAG is that, for example, you can have your DBT DAG as a task, as one of the nodes in your Airflow DAG. There are actually different patterns of how to run DBT in Airflow. You could, for example, I've also seen people schedule each individual model and map each individual DBT model to a task in an Airflow DAG. In this case, I'm kind of treating it in this example as one unit. So my DBT DAG corresponds to one node in my Airflow DAG. So that's the second component in our stack. And then the third component is a tool called Great Expectations. And again, disclaimer, I work for Superconductive, which is one of the core maintainers behind Great Expectations. Great Expectations is an open source data validation and documentation tool, which lets you express what you expect from your data. So there's going to be a lot of expectation related puns in here. So as an example, in Great Expectations, you can say the values in this particular column must always be between the number 1 and the number 6. You can then use that expectation or that statement to run it against your data sets. And we call that process validation. And then your validation either passes if your data matches your expectations, or the validation fails. So that's the concept of Great Expectation. And again, it's an open source tool written in Python. So this is all very available for everyone. Right, I'm going to dive a little bit deeper into Great Expectations, mostly because I assume, again, you're probably all familiar with DBT. A lot of you might be familiar with Airflow or other workflow orchestration tools. Great Expectations might be sort of a little bit newer to you. So I'm going to talk a little bit more about that. So first of all, what is an expectation? An expectation is, again, a statement about what we expect from our data, and it can be expressed in code. So what that means for Great Expectations in particular is that you write your expectations, your statement in plain Python code. They're just straight up Python messages. In this particular example, I have a method that just says expect column values to be between. I can specify the column, I can specify a min and a max value, and that's my expectation, which I can, like I said, run against my data and then validate the data with that. Great Expectations also allows you to store your expectations as in JSON. So you can serialize that and for reuse later in the game, basically. So we kind of follow a test as configuration type pattern. And then lastly, we can also translate these expectations into human readable format. So I'll show that in a second. In our data, in our validation output, we also have some human readable components. Now the question is, great, we have these expectations, or we can write these expectations. How do we actually create them? How do we generate them? And there's two different ways to do it, or three actually. One is you can really just write out all these statements here in Python, as I've just explained. If you know your data pretty well, or if you have, for example, domain experts that give you some criteria, or if you have your stakeholder that give you almost like a user acceptance testing that give you sort of acceptance criteria for your data, where they're saying, okay, I need these kinds of values, I need this kind of distribution, I need these columns to not be null, for example. You can just write all these statements out and create your expectations with that. Another option that comes built into Great Expectations is what's called automated profiling. So we have a process of scaffolding expectations, which is basically the process of looking at historical data. From whatever the profiler sees in that data, it derives expectations and then creates those expectations. So in this particular example, if the profiler only sees values between 1 and 6 in the historical data, it will create that expectation, say, okay, I only see values between 1 and 6. That's what I assume the data is going to look like in the future. Having said that, of course, your historical data is not always representative of what you actually expect from your data or what values you actually allow in your data. So we think there's always some amount of domain expertise and some checking and some addition and some fine-tuning of your expectations in order to get to that final set. Once you have your expectations, they're actually stored in something called an expectation suite. So that's like your bundle of expectations in the same way as a test suite. Once you have your expectation suite, your set of expectations, this is the same graphic I've already shown a little earlier. You can use that expectation to throw it at future data or any other data that's coming in and validate it and then see, okay, does this actually match our expectations? And I know this is a lot of expectation puns here. Right. And finally, one feature that Great Expectations also has is called data docs. So data docs basically takes your validation results. So it's not just pass or fail, but it actually also tells you to some extent why it didn't pass. So why an expectation failed. So in this particular case, in my example, I had an expectation. I hope this is big enough here that says the values for this column, again, must always be between 1 and 6. And the validation failed because it actually found 1,579 unexpected values. And it tells me which unexpected values actually occurred. And in this case, I had some zeros in that particular column. Right, and that's what's called data docs. A lot of our users call them data quality reports, which is also accurate. We like to call them or think of them as data docs because they're really kind of documentation about your data. I really enjoyed the keynote talk this morning about metadata, or not keynote talk, but like an earlier panel today about metadata. So this is sort of going into that territory of it's documentation, it's metadata, data about your data. Great. All right, so now that I've done the introduction to DBT, Minimal, Apache Airflow, and Great Expectations, I am going back to our stack. So how does this all fit together? And this is really, if there's one slide you remember from this talk, I think this is one thing that is really key to what I'm trying to bring across. You should really test your data whenever there is a handoff between teams or systems. I actually really like this like the idea of a data pipeline as sort of a Rube Goldberg machine where things are kind of set in motion and happen and depend on each other. And whenever there's a handoff, you want to basically ensure that the previous step was executed correctly and it actually did what you expected. Whoa. And then you can move on to the next step. So at a very high level, before we actually go into the example, at a very high level, this is what this could look like. So if you look at it from left to right, you start with your source data. And this is like a very generic, abstract model of a data pipelines. We know all models are wrong, but they do the job. So bear with me. But we have our source data from a database, for example, files from an API. We validate the source data. If we fail, we have some kind of response. We could even halt execution of that entire pipeline. If we pass, we move it on to actually extracting that data to a staging environment. And then we continue with that. We validate to ensure that the extraction actually was correct. And then we run the data transformation, and then we validate that the transformation was correct. And finally, we promote our data to production. We could even add another test here. I just don't want to get go too crazy here, but you kind of get the idea of every time there's a handoff, every time the data is moved around between either different teams or different systems, there is a validation step. All right. Now we're actually going back to the stack. This was just a little detour to sort of a slightly more abstract concept. Okay, so we're getting very specific now. So I hope this wasn't too harsh a segue. Imagine you have an airflow project, right, where you usually have something for your DAGs. You have your DBT project or your DBT DAG in there with all your models, and then you have a great expectation setup. So just assume this is kind of what a typical project could look like. And then in the stack file, you have several tasks, right? You have, in this case, and this is just my example, I have a few validation tasks where I'm using the Great Expectations Airflow operator. I have a few just loading tasks that are, in this case, just pure Python. I'm running DBT, so I have the DBT run operator. So these are all built into Airflow. You can use those operators. So just imagine this is kind of the project that we're working with. And this is what the resulting DAG then looks like. So we validate the load, run DBT, validate the analytical output, and then publish our data. And so this is kind of the last part, and maybe also sort of the meat or the most interesting part for a lot of you folks in the audience. I'm actually going to show some examples of the types of tests or the types of validations that can be done at each individual validation state. So first of all, let's start with the source data. And in this case, this would be a case for Great Expectations, where you can test that the source data matches an expected format. For example, you have the correct number of columns, you have the correct data types, your row count is similar to last month's, things like that. One example that we've had from one of the teams that use Great Expectations that's really cool is they have an uploader tool where data producers, stakeholders actually upload CSV files, and they run Great Expectations to validate the uploaded CSV files immediately and provide feedback. So that's a pretty cool use case for that. The reason why you want to test here already is basically if stuff is already broken there, what's the point in kind of continuing your pipeline, right? Or maybe you might want to continue and that's fine, but you want to, alert someone or log it somewhere or do something. Right. The next step is the validating the actual source data load. So in this case, we should probably test that the source data load was successful. So, and most of the time, this is something like no rows were lost compared to the source data. Or one thing I always run into, maybe I'm just like really bad at this in general, but is like I've had a lot of pipelines break, a lot of issues because of special characters in specific fields and text fields, or you might be truncating floating point values, so things like that. So again, every time you move your data around, you probably want to add a validation step. And again, this is still outside of our DBT DAG. All right, next up is our stage where we actually run the DBT DAG. In this case, I'm not actually focusing on validation while running. One thing that I find personally, and I think for us as a team, when we use DBT, we find really cool is that you can run DBT tests and write DBT tests during DAG development, especially to check for what I call the integrity of transformations. So the idea here is, and bear with me, this gets a little bit abstract, but the idea for me is that you have a little bit of a distinction between testing the actual data and testing the code that transforms the data. And in this case, my focus here would be really on testing the code, making sure that if you're doing a join, you don't have a fan out, for example, or if you're doing anything else, you don't have null values in a particular column. So, and you can really run these tests during development, for example, to make sure that the code you're writing doesn't botch your data. And then finally, in the last stage where you can validate your analytical output, I think this is if people are using DBT tests already, and I assume everyone's doing this. I think this is one of the key features that people get excited about with DBT, is again testing the integrity of transformations. So really making sure that the code that you're writing actually did the right thing. In addition to that, Great Expectations has a lot of off-the-shelf methods for really complex tests. So distributions of values, for example, so we have a KL divergence test, where you can really have slightly more complex tests that you don't have to necessarily write custom SQL for that just work out of the box. In addition to that, you can generate data docs, which basically means that your users will get a data quality report or documentation about the state of your data quality at the final stage. That is pretty much it. So I hope I've given you a good overview of the different types of tests that are possible here. And again, this is a very, very heavily simplified model. So there's a lot of other variations, obviously, that you can think of. So in summary, please test your data, test it in multiple places, and test it with different types of tests. Thank you very much. I hope this wasn't too fast in the beginning. Really, really looking forward to chatting with everyone in the Slack channel later. Thank you.